Hello everyone, my name is Jorge Sarta and today I want to share with you my enterprise data management plan for Tau Mobile Biomechanics Lab. First of all, I want to share and talk more about what is the business or the business meaning for Tau, business process. Tau is a mobile biomechanics lab which is looking to know or give to youth athletes the all data, all the aspects of the data for the body composition, which is will help them to improve their performance. So any athlete in process to grow to become a master athlete, they need to get the amount of data and understand how are they balanced. For example, the body composition, the muscle power, and by getting all this information, Tao has developed a technique that assists athletes in avoiding injuries, resolving body composition concerns, and enhancing their development performance. Tao has a 9 months program, employs a foot pressure platform and motion sensors to collect data, generate workout regimens, and conduct progress evaluation. Tao business process encompasses several distinct features that must be configured independently. To enhance the performance or development of youth athletes, Tao devised a research and development plan to seek to coordinate engage Tao personnel, prioritize Tao's investments, and capture scientific possibilities. This technique consists in 6 steps. Concentrate and breakthrough technology to address unmet demands of several injured athletes. Pursue objectives that have been verified in people. Maintain and comprehensive arsenal of training methods that emphasize body composition, concentrate on ROI and operational effectiveness, capitalize on foreign innovation, demonstrate the benefits of Tau evaluation method for improvement. To achieve the objectives of my strategy, we have prepared the following EDM plan. So how I terminate different stages like outcomes, planning, analysis, design, development, and business integration. So, in planning support, like the business plans, I detect the enterprise infrastructure evaluation, which prioritize business areas, and then preliminary project. So all these areas are connected to the applications analysis, source data analysis, scorecard, dashboard analysis, where the science behind Tau, they can pretty much understand all the scores from the athletes, security requirements analysis, and metadata analysis. Then I will connect these areas to the database design, the ETL process, the framework model, score dashboard designs that are connected, and the security model design, which is very relevant. And then the whole system, the prioritized phases coming to the GAP analysis, source data analysis, the framework model department, Q scorecard and dashboard development. So in each stage, I have determined we need to know the scorecard and dashboard development, and then the security model. As a result, we get the business validations and then business area implementation, which gives us the enterprise integration, which continuing assistant for solution. And pretty much the cycle repeats itself. So after this, what I pretty much terminate is the architecture schema, as you see in this diagram, is all the structure for the Tau architecture schema system. As you see here in the body composition, posture analysis, static and dynamic, baropodmetric, dynamometer, cardiac variability, muscular resistance, estivallometry. This is all the assessments Tau has been created for improve athletes' performance. So pretty much these assessments talent to the data analyze department the different situations for each athlete or each sport person. So here we create some data and then are interconnect to the different aspects of the architectural schema. So the private databases, which is the system and the software Tau already on, the applications, the microarrays, foot pressure platform, and motion sensor, the flat files and spreadsheet files, which came from outside sourcing, they are connected and comes to the ETL process, and then go forward to interconnect with all these final tools. For example, decision tools, data mining tools, reporting tool, statistical analysis tool, and visualization tools, or in this case Power BI, which is going to be the software Tau is looking to use for the data visualization part for their process. Now the dimensional model or suggest model mostly adheres to the modeling strategy base and conceptual structure. The suggest model will satisfy 6 criteria, like support the integration of multiple data sources, is resilient in the face of changing data sources, support flexible transformation, can be easily deployed in appropriate implementation environment, is comprehensive enough to handle the various extractions, modification, and loading operation, and is easy to create and maintain. The data source might be either structured or unstructured databases or sources. In the case of structured citations, the participating database tables and characteristics are utilized directly as the base source. However, in the case of non-structured quotation, a conversion step is required to turn the non-structured head into a structured one. From design perspective, a single conversion construct can convert any unstructured source into a structured database. However, from an implementation perspective, each kind of unstructured source will have its conversion model known as a wrapper. Wrappers are specialized software routines that automatically extract data from several data sources with varying formats and transform it into a structural layout. Wrappers' usual responsibilities include retrieving data from a distant resource, searching for, recognizing, and extracting recurrent data, storing this data in a suitability organized format to facilitate future process. And finally, as the data reach its final suitable format, is loaded into the proper data element in the destination data warehouse schema. The data might be immediately imported to a specific transformation function or extract from required temporary staging tables. Now, the staffing plan, I determinate which will be necessary to develop this plan is here in this structure. So we have the CEO, which is director enterprise reports to the CEO, and then the director enterprise will have strategic planning manager, data delivery, data analysis and design, and data development. And here, the strategic planning outreach will have a project manager, which is going to set up the whole project and do the follow-up. Then we're going to need information architect, solution architect. And finally, we have to implement the training, education, and communication for the internal group. In the data delivery aspect, we're going to need a BI engineer, BI analyst, test lead, and a data scientist. For data analysis and design, we're going to need business analyst, data modeler. And for data development, we're going to need a database developer and infrastructure engineer. Now, this is the plan I estimate for the enterprise data model. So the 3 months, so I break down by 3 months, 5 months, and 1 month. So the first 3 months, assessment initiation, PMO, project management operation maturity model, program initiation workshop, PMO strategy, governance process, and project assessment. And then we're gonna pass to the phase of planning, project planning workshop, project management planning, cost planning, administration controls planning, and then communication strategy. So in between these 6 months, we'll cover all of these aspects of the plan. And then for almost 5 months, the execution, well, we have to achieve the plan execution, the cost management, tracking, monitoring, controlling, the distribution of information and performance reporting, mentorship and team building, management of the program administration, and the goal is for 1 month, the transition to see PMO, project management operation turn over to the team and the deliveries. Implementing this solution will help Tau researchers to better their research by boosting the speed of data processing, preserving data quality, and making it simple to convey these facts to the scientists so he or she might focus on scientific endeavors rather than administrative tasks. The ultimate objective of the execution of this approach is to build an awareness of how the various body parts are constructed to encode them and give adolescents, athletes with the correct physical plan. It is not the quantity of information that is crucial, but rather its significance and the capacity to comprehend it. The economic advantages are obvious but often difficult to quantify. It is costly to establish a transportable biomechanics laboratory. In addition, rack mount computers, high throughput sequencers, and the technical personnel required to operate this business are all costly. If the mobile life is well managed over time, the savings are possible. This period is proportionate to the lab's capacity to generate revenue and become profitable. Finally, the most essential advantage is the humanitarian one, using the business intelligence solution to identify solutions and instill healthy habits in the youth population while enhancing the precision of sports development. Lowering injuries is the solution greatest benefit. And finally, here breakdown what I think for a start this plan I'm gonna need. So I'm gonna use SolarWind Enterprise Operation Consoles. The annual subscription is $13,732. The SQL server per instance for database insights, the annual subscription 1 to 4 license obviously is $1,550. And the SolarWinds Enterprise Operation Consoles annual subscription is 13,732. So the subtotal for technologies is gonna be $29,014, but I didn't add Power BI license because the company already has the enterprise plan for all Windows suite. So all the Windows Office covers the Power BI software. And here I determine the payroll the company will gonna need is strategy manager, information architect, BI analyst, data scientist, database developer, BI engineer, and give me a subtotal of $591,590 for a grand total of $620,604. So this is the total or the goal to get this total for the project. That's all I have for you, and thank you so much. I'll see you next time.